Scitek is excited to be the only ANZ-based solution provider for processing of medicinal cannabis from flower to API and beyond. Scitek will provide you with exceptional confidence by providing manufacturing workflow and honest equipment selection advice, delivering GMP-ready and ASNZ standard compliant equipment, protecting your investment and operation uptime by offering competent and responsive warranty and service support. Scitek is proud to represent global cannabis industry leaders Scitek is looking forward to working with you on your medicinal cannabis equipment manufacturing journey.
Welcome everyone. My name is Tobias. I'm the Managing Director at Scitek. We're proud to be the only ANZ-based end-to-end equipment provider for cannabis manufacturing, from flower to API and beyond. My talk today will focus on CO2 and ethanol as the two mainstream extraction solvents used in the cannabis industry. The intended outcome is to help you make a qualified decision on what extraction solvent is best suited for your business. Scitek was established over 30 years ago as a vacuum technology provider. Cannabis processing involves many steps where vacuum technology is used. Given our experience in chemistry and pharma industry, Scitek was well placed to support a growing cannabis industry from legalization in Australia about 4 years ago. It's important for you to know that we offer many technology options from a number of suppliers. We believe strongly and practice unbiased recommendations. This is very much unlike manufacturers or exclusive sales reps who will only ever want to recommend you their specific product. To add value to your business, we have invested heavily on in-house cannabis processing expertise, and we can draw on a network of industry specialists. Here you can see a typical cannabis manufacturing workflow, starting from dedicated terpene extraction and finishing at isolate level. In this scenario, there are a number of product break-off points. Most commonly, these are oil as raw or activated oil, distillate, and isolate. Now, this workflow does not mean your process will have to look exactly the same. For example, decarboxylation is generally done after drying when CO2 extraction is used. It's also possible to skip some steps altogether, depending on what technology is facilitated. Now let's jump into extraction, the focus of my presentation today. This is a very high-level overview of all mainstream extraction solvents. We have microwave assisted. This is mostly used for terpenes. Steam extraction is very common in the food and fragrance industry, but only works well for low boiling point volatiles unless high pressure is applied, which can have significant drawbacks for cannabis use. Ethanol is one of the top industry choices. It works for virtually all plant constituents. CO2. This gas is actually not a very good solvent, but through high pressure and correct temperature, we can boost its efficiency. However, as you can see, it often needs co-solvents, and there is a significant discussion to be had around post-processing. Hydrocarbons are the industry standard in the recreational industry, as it allows many artisan-style products such as shatter, wax, and diamonds. Water extraction has been around for many years, and it's really more a mechanical separation rather than an extraction. It's commonly used to make bubble hash for recreational purpose. It makes little sense in the medicinal space at this time. Let's focus on ethanol and CO2 moving forward. CO2 as a solvent is an interesting story. The main drawcard is the possibility of doing a full spectrum extraction, commonly understood as terpenes and cannabinoids. A discussion ought to be had around what full spectrum product actually is. If you're interested, my colleague Andre has previously given a talk on demystifying full spectrum cannabis. Suffice to say, full spectrum is really a marketing term. The other key reason why operators choose CO2 is the image of CO2 being benign and solventless. I believe not everyone who decides for CO2 has fully researched whether the solvent-free claim actually stacks up. It does not, as virtually 100% of all operators will use ethanol in the winterization process following CO2 extraction. For me personally, the main disadvantage of CO2 is the fact that it is actually a terrible solvent. Market-leading CO2 cannabis extractors are currently achieving 4-hour runtimes for decarb material, with most running 6 to 8 hours to achieve good yield. Compare this with ethanol, which needs 5 to 30 minutes typically, but I know operators who soak as little as 3 minutes to get extraction yields comparable to CO2. Ethanol is safe. We all drink it, and probably more than we should. I find it funny when I have meetings with CO2 advocates who go on to tell me how bad ethanol is, and they do that over a beer at the pub. One downside ethanol has: most low-boiling terpenes, so-called monoterpenes, are generally lost in the ethanol during extraction and cannot be recovered easily. This is an overview over CO2 states based on pressure and temperature. You can see the areas of subcritical and supercritical state. Subcritical is below the critical point. It runs generally at 55 bar and 280 kelvins. Subcritical is used for terpene extraction. Supercritical is above 74 bar and 304 Kelvin, typically used for cannabinoid extraction. But beware, you also get unwanted fats, waxes, lipids, and chlorophyll, which generally requires remediation through winterization and filtration. This is a typical CO2 extractor CO2 flow circuit. Our extraction vessel extractor is under supercritical conditions. The gas drops back into the gas phase after the extraction vessel and enters the separator where your product will collect. The gas is then condensed into liquid phase before being compressed up to pressure again by the CO2 pressure pump. Your key CO2 extraction parameters are pressure and time. By adjusting your main CO2 extraction pressure, you can obtain a rough level of selectivity between terpenes and cannabinoids. Some CO2 equipment manufacturers market shelf-ready oil as a key benefit of their systems. It is worth noting that any CO2 extractor with good pressure control can produce such oil. It simply means you stop your extraction before most unwanted byproduct is extracted. This comes at a significant cost, however, that is not often spoken about. Your extraction yield, as in how much of my cannabinoids do I actually get, will be suboptimal. That will be costing you real money. One solution could be to fractionize and continue runs. You would then have to post-process the dirty fraction to optimize yield, thus income. There are a few manufacturers on the market who offer systems that can reach as much as 6,000 psi pressure. The advantage of higher pressure is higher extraction yield and efficiency, as in how much cannabinoid content do I collect and in what time. The disadvantage will be an extract that is heavily contaminated with chlorophyll, thus requiring more extensive cleanup in post-processing. How is CO2 crude, or butter as it's sometimes called, cleaned into a nice oil? The process is called winterization. The solvent of choice is ethanol. Ethanol is easy to work with, clean and safe. Ethanol stays in liquid phase down to about -60 degrees Celsius, so you can cool your winterization mix easily to precipitate the unwanted fats, waxes, and lipids. This is followed by a winterization step to remove the now solid unwanted fraction. Multiple repeat winterizations and filtrations may be required. We're now moving on to ethanol extraction equipment. We know the process is very simple. Soak your biomass in ethanol one way or another. Filter the crude containing ethanol and oils from the biomass and then post-process. Ethanol extraction is fast and efficient. Generally, soak times are 5 to 30 minutes. It is worth noting that ethanol extraction is done either warm or cold. Warm ethanol extraction requires Dewax to remove fats, waxes, and lipids. Cold ethanol extraction is highly recommended because it does not extract fats, waxes, and lipids in the first place. It requires a typical extraction temperature below -40 degrees Celsius. The system you can see on this slide is a fully automated all-in-one ethanol extraction system. On the far left side, you can see the extraction vessel. Everything to the right of it is automated post-processing. This machine will extract, strip waste biomass of residual ethanol to reduce solvent cost, and minimize waste biomass cannabinoid content. Filter fines, color, and smells as needed. Recover the ethanol from the oil for reuse or disposal. Decarboxylate your oil. I'm showing you this to illustrate how efficient ethanol setups can be. This entire machine can be operated by one person. A quick summary on the advantages and disadvantages of CO2 and ethanol extraction equipment. Both technologies are available in automated systems. Both are scalable from small to large operations. However, CO2 in cannabis becomes commercially unviable at some point. AZNZ compliance certifications are required for both technologies. Aside from electricals, most notably, two standards have to be complied with: the pressure vessel standard for CO2 and explosion protection standard for ethanol. Here's an overview again on the various technologies, but this time looking at your typical market entry points for AZNZ compliant pharmaceutical production tools. I have only looked at products from manufacturers that I consider suitable for a pharma GMP production environment. CO2 generally has the highest market entry cost and the lowest throughput capacity. The limited capacity is purely a reflection of the long extraction times required. Now let's have a look at an example business case. Please be aware that this example is purely for illustration purpose. It has been extremely simplified to suit the purpose of this presentation. Having said that, my team has run many models similar to this across a wide range of production volumes, from as little as 5 tons per year to over 100 tons. The fundamental commercials are consistent. For this example, we have chosen an operator who plans to grow 40 tons of wet flower per year. This is about the average long-term production target we have seen from our customers. The model only considers machine cost and labor cost. For simplicity, labor hours are matched with machine hours, meaning one operator runs one machine at all times. We have not considered biomass cost, consumables, waste disposal, energy, and overheads. 2 production scenarios: CO2 with a workflow of subcritical CO2 for terpenes, decarboxylation, supercritical CO2 for cannabinoids, winterization, filtration, and ethanol reclaim. Ethanol with a workflow of subcritical CO2 for terpenes and subsequent ethanol extraction and post-processing in the all-in-one system we have seen earlier. Whether or not you're actually going to be interested in terpenes is up for discussion. At this time, the focus in medicinal cannabis is very much on our main cannabinoids, but I believe this will change. In the recreational industry, terpenes are very important as a way to create individualized product and consumer experience. This table shows you the production throughput capacities of the various production tools chosen. We have picked this to minimize cost, but in line with overall production throughput. The critical path is always going to be the CO2 extraction because the process is so slow. I have worked with 4-hour runtime for cannabinoids, which is market leading. I should highlight that all of these are Scitek products. However, they're very popular in the wider industry, and I believe comparable alternate products would produce similar results. Based on our assumptions and selected equipment, we end up with the following important data. Your production step throughput capacity per hour. Note, there is a huge variance between CO2 extraction on one end and filtration on the other. I have picked the smallest GMP filter press we have available to use, and its capacity is clearly huge compared to our production capacity 2 by 50 liter twin vessel CO2 extractor. What is interesting is that your CO2 cannabinoid extraction capacity even when using a twin 50-liter vessel continuous production system, is too low for you to be able to process the 40-ton capacity annually. You can see it would require about 14,000 hours, but a full year has only got 8,760. In our model, we have invested into 2 of these CO2 extractors. You can see that the CO2 terpene extraction machine has plenty of capacity left. We will use this spare capacity by running cannabinoid runs and terpene runs, bringing the overall processing time well within range. If we now translate our capacity and processing times into equipment and labor costs, then we get the following picture. In the CO2 model, we need to buy 2 CO2 extractors, 1 decarb system, 1 winterization tool, 1 filtration tool, and 1 solvent evaporation or solvent reclaim tool. This will be costing you approximately $3 million, which, by the way, is a very common number for our customers and the capacity range we're looking at. In the ethanol model, we need to buy 1 CO2 extractor for terpenes and 1 ethanol all-in-one extractor. You can see the initial investment between both options are approximately within 10% from each other, with the ethanol option costing $400,000 more. Now let's look at labor cost. To emphasize again, we're looking at 1 hour labor per 1 hour machine runtime. This is a simplified model, but even in more sophisticated business case calculations we have done, the ultimate result will not fundamentally change. The numbers speak for themselves. The combination production setup of CO2 and ethanol saves almost $1 million per year in labor cost. Even in the first year with the higher upfront investment, we already save over $500,000. Keep in mind also the huge spare capacity the ethanol extractor has. This is an income capacity you can use to grow your business or to toll process for others. My message here is simple. Consider production cost when making a decision as to what extraction solvent you want to use. To conclude our solvent comparison, it is very clear ethanol is the better solvent to use from a production cost and throughput perspective. The CO2 equipment is considered a solvent-free extraction method, which is true, but don't forget, you need to post-process with ethanol. All solvents have advantages and disadvantages, but so long the final product complies with residual solvent requirements set by MedSafe, TGA, European Pharmacopoeia, and similar standards, you can use them. For medicinal cannabis, and this is our focus currently in Australia and New Zealand, I believe there is an advertising ban, so you will not be able to market a solvent-free through CO2 product to your patients. I believe there is a place for both solvents, depending on your customer requirements, production cost, or simply business strategy. If it was my business and I wanted to offer a broad spectrum product, then I would set up both. CO2 with focus on terpenes, but you can run cannabinoids as required, and ethanol for cannabinoids. If my focus was on major cannabinoids only, then I would always choose ethanol. Another major point, I encourage you to invest into automation. Labor costs in Australia and New Zealand are amongst the highest in the world. Machines have comparable costs wherever you go. If you want to be competitive on a global market, then automation is the key. We know that from many other industries. Some final words on production equipment selection. Make sure you buy ASNZ standard compliant tools only. We have already seen a number of customers buy equipment that required extensive upgrades or modifications after delivery. Some were unable to be operated altogether. Make sure your equipment comes from manufacturers with a track record in pharmaceutical GMP equipment manufacturing. Especially the US cannabis equipment manufacturing industry is still only learning about GMP. This takes years to master. Local service is important to protect your production uptime and support your ongoing GMP master plan with local traceable calibration services and maintenance. Thank you for your time today. Following this presentation, I hope you now feel better informed about the advantages and disadvantages of ethanol and CO2 as extraction solvent. Please feel free to reach out to me directly if you would like to have copies of this presentation. Follow us on Instagram for continuous updates on cannabis tools. Thank you.